start the recording and share the screen also. So we were studying this property that autocorrelation for a stationary process is actually an even function, all right? Even function. Next is cyclostationary, but we can leave that. It is not part of our course. So now we go to multiple random processes. Achha, here one thing I would like to basically emphasize here that I will try to that because now I am devoting more time to stochastic processes, as you could basically see that students were not aware. So that is why we are trying to cover more of the random process. So there will be a change in the outline, which I will also like you to see here that so the outline would be a bit change, and now we will give more time to random processes. So we will study stochastic processes, ESD and PSD, you can see here. So we also studied white and stationary processes, but we will also be studying multiple random processes as well as white noise and Gaussian noise. So these things will be added up. So we'll be devoting more time to the random or the stochastic processes in this course as compared to the original outline, because originally I thought that students would have studied that. So that is why we will be giving it more time. So coming back to the course now. So the next concept that we have to understand are the relationships between the multiple random processes. How can you generate one random process from another random process? So one of the most commonly used functions we all know are the LTI systems. So if you feed an input to an LTI system, you know the output is actually the convolution of the input with the impulse response of the LTI system. This you have studied in your signal systems courses. And so what will happen here, that now we will take a random process and we will feed a random process to an LTI system, and we will try to observe what happens to the output function. So we know that the output function will be the random process convolved with the impulse response. Okay, and hence now you will be getting two signals, and in effect you will see that the output will also be a random process. So questions will arise about the relationship between these two random processes. One is the input random process and one other is the output random process, which comes out of the LTI system when the input was a random process. So the first thing is that when will these two processes, one input and one output, when will they be independent? So they will be independent if I take for any or for any mn, any positive integers, I define my times, and at all those times at all those instances I take the random values of my x as well as the random values of my other function y, and if those random vectors they come out to be independent, then this means that the two random processes are independent. Similarly, if these two vectors, random vectors, which I've just made up by myself, they are uncorrelated, then this means that the random processes x and y are uncorrelated. All right. And we have studied this in the previous lectures, that if I say that the process is independent, then this means that the process is uncorrelated with respect to random variable. If it is independent random variable, two independent random variables, two random variables are independent random variables, and they're also uncorrelated, but not vice versa. Only for the Gaussian random variable, if it is uncorrelated, then it is also independent. But for others, it will not be so. Similarly, here we can see that for processes also in general, if they are independent processes and they are uncorrelated processes, but for Gaussian process, we know that if it is uncorrelated process, then it is also an independent process. Then Gaussian processes are also independent. So we can also define cross correlation. Auto was between same instances of a signal, or same signal instances. Cross will be instances of two different random processes. So they can be defined as follows. And you can also see here T1, T2 will be equal to T2, T1. But then T2 you will put Ry x T1. Here you are also doing the same thing. So this property is also satisfied. Cross correlation we have also seen, or relationship between two random processes. Similarly, we can define whether the random processes are jointly White and stationary jointly. So if two random processes are WSS, so this means if two, you have to use the word joint, or they are jointly stationary or jointly White and stationary. So they will be jointly White and stationary or jointly stationary, provided their cross correlation is a function of tau, or T1 minus T2. And you can also see, we saw previously that Rxy was equal to Ryx T1 T2 T2 T1. So if T1 minus T2 is tau, then T2 minus Tn will be minus tau. This is the property will be satisfied only for stationary processes. All right, the time is up. I won't take more of your time now. I will just mark first of all the attendances so that roll number 4.
Yes, sir.
Roll number 6.
Yes, sir.
Roll number 2. Roll number 2 is absent. Roll number 2. 2. Achha, roll number 3.
Present.
All right. Roll number 9. Roll number 9. I think absent. Roll number 10.
Present.
Okay. Roll number 18.
Present.
Roll number 21. 21 is absent. Roll number 24.
Present, sir.
All right. Roll number 27.
Present, sir.
Present, sir. Got roll number 28. 28. Right, absent. Roll number 30.
Present, sir.
Roll number 34. Roll number 34. She was present in the first session because she answered one question, I think, or something. She said, oh, she said, but she is not. I think she was present in the first session. All right, so I will mark her present. All right, thank you very much. So I will end the lecture here. So the new lecture, I think, will be on campus from the next week. So hope to meet you, inshallah, from next week in the next lecture. All right, thank you very much.
Okay, sir. Thank you.
Thank you, sir. Allah Hafiz.